takes a little bit more work. There are ways you can do it, but it takes a lot more work. Unfortunately, using standard map is an exercise in slowing down code. Okay, if you think that a linked list is bad, maps are worse. I'm going to be really blunt here. I have no code that I have ever worked with which should have used standard map. I don't believe there are problems in real software that it solves effectively. Okay? It's maybe a somewhat radical position, but I would actually just strike this data structure from the library if I could. Okay, why do I think that? That seems radical and crazy. So here's the thing. Standard map, it is a linked list. But it's a linked list where all of the non-traversing operations are essentially removed. Okay? Because if you want to insert into it, you have to traverse it. If you want to remove from it, you have to traverse it. Even if you play all the tricks, you pull out the insertion hint element into your map so that you immediately jump to the right node of your binary search tree to insert, a decent chunk of the time you're going to rebalance the tree, which is a terrible traversal, okay? And one of the slowest things you can do on a cache-oriented architecture, okay? Standard map is terrible. If you absolutely must have a sorted associative container of things, then what you really want is just a sorted sequence of things and binary search your way to associativity on top of it, i.e., just use a vector. Don't use map. But wait, unordered map will save us, right? Unfortunately, unordered map will not save us. Standard unordered map is to me much more frustrating. I despise standard map because I don't feel it's a good tool for any job. Right? It's a bad tool for a rare job. But standard unordered map is more frustrating to me because this is actually the job you usually have. You usually just want to associate a key to a value. And an unordered map, despite the somewhat cumbersome name, seems to do exactly that. But it does so in a terrible way. Okay? So it is essentially required, based on the standard, to be implemented in terms of buckets of key value pairs. And I can't express to you how much of this implementation detail bled into the interface. You can actually get bucket iterators into an unordered map. How many folks knew this? You can get a bucket iterator into an unordered map and iterate the elements of a bucket and observe where they start and where they end. Right? You can also get an iterator over the buckets in the map rather than over the elements. It's incredibly hard to build a map which does not actually use separate buckets from the hash table as a consequence. All right? And so what you end up with is this great hash table which has a pair of a hashed value and a pointer in it. Sorry, usually just a pointer in it, right? And this pointer points to, a linked list of the key value pairs that are in the map. So we're back to linked lists. Despite the fact that we were going for the efficient data structure, these hash tables and all the other great things, at the bottom it's actually a bunch of linked lists. All right, they're back. So the performance of this is actually pretty terrible. You will always have a cache miss when looking up into an unordered map. I mean, the first time. You might get away without having a cache miss the second time, but the first time you're essentially going to take a cache miss, because you're going to be chasing too many pointers. It's extremely frustrating, okay? And the other thing that's a little bit frustrating is it's not that we don't know how to do this better, okay? A good hash table looks something like this. You don't use buckets. You use open addressing into a table of key value pairs, right? Just a flat, contiguous table of key value pairs. You use local probing to find where to place values when you have a collision. The local probing here is key, okay? You will have collisions in any hash table implementation. You're going to have them. You have to plan for it, okay? By finding an adjacent or a quadratically adjacent node to insert your key value pair into, you actually maximize the cache locality of handling a collision. The difference between doing something like what I describe here, an unordered map, is massive. We're talking orders of like 10x performance reduction sometimes when this is in your critical path, when you have a high load factor on your hash table. It's really, really bad how this actually performs in the real world. So It would be very nice if we could do this. The other thing I do want to mention is if you design your hash tables this way, you then have a constraint, which is a little annoying. You have to keep your key and values small. So if you have enormous values, right, suddenly they're a little bit more awkward to deal with. But there's an easy solution to that. When you actually have an enormous value, like a really big chunk of data, that's when chasing a pointer starts to make sense, right? And so you can put your value as a unique pointer to the actual large data.